In this lesson, we will discuss how to verify if a certain element is inside our list or not. So this can be called the contains operation, for example, and this will be critical for our exercise where we want to verify if a certain word is in the dictionary or not. So we have a file with a lot of words, and the idea is that if the file is if the word is on that file, it means that it's spelled correctly. Otherwise, it might not be spelled correctly. So we can implement kind of a spell checker with this. So our contains function would be something like this: fun list contains, that given some piece of data that is an integer, and this would be our list. And we return here a Boolean, because we return true or false. True if it's there, false if it's not there. So if our list is like this, one, two, three, we want to verify if the number 4 is here. We go here, it's not here, we move, it's not here, we move, it's not here, we move, we reach the end, so it means that it's not there. And of course, if we want to search for number 2, we check here, it's not, we move, we check here, it's here, so the item is there. So we have done already a few problems with this, so I hope that you can solve this by yourself, and please try it and look at the solution after you try it. As usual, if the list is empty, for sure the item is not there. So here we can confidently return false, because there's no way that the item is there. Otherwise, we do the usual that we always do. Var r equals list, which, if this is our list and our r points here, while r is not null, we want to check if r dot data equals to this data. And if that's the case, then we return true. Otherwise, we just move on. So let's see how this works. We want to search for the number 2, for example. Here we start with the r here. If r.data equals data, r.data is 1, so we don't return, and we move on to the next. And now r is different than null. Yes, it's different than null. r.data equals data. Yes, because our data that we wanted is 2, so we return true and our function finishes. And in the case that we want to search for the number 4, for example, we start our r here again, and while r is different than null, r.data equals data. It doesn't, so we move the pointer here, and then we look back here, and we check again if the data r.data equals data. It doesn't, so it moves again, and it's not, so it moves again. So now we are here. R is different than null. No, it's actually null, so here we return false. Return false. So that's it for our contains. And let's also talk about the time complexity of our contains. In the worst case scenario, the item that we want to find is not there. And in that case, it means that we traversed all the n elements, right? Because the only way for us to find out if the element is there or not is to go through all the elements. So this would mean that the complexity of our contains is O of n. But this is already, or should be, if you are already getting a grasp about these algorithms, that if we want to search for, let's say we have, in one file, we have a book, and in another file, we have our dictionary, and using the append operation, you saw that it was the time complexity of loading the file to memory was O(n squared. And you learned already that if the input is too large, that an O(n squared algorithm can be very slow. And we solved that problem. But now we have this problem that's searching, because we have to verify on the input file, which is the book, we want to verify if all the words, by book could be an article, could be anything that you write, doesn't matter for the example. Just you have an input that you want to validate if all the words are spelled correctly or not, basically if each word is in the dictionary or not. But the contains operation is O of n. So if you want to verify if all the words are in the dictionary, this would mean that you will repeat n times O(n) operation, which of course will be an O(n squared). So you should be already wondering how slow this will be, and we will look in the lab sessions, we will look into this. But you know already that this is something that we have to solve, because it will not be sustainable if the input is very large, that we have an O(n squared) operation. So how could we solve something like this? I will erase the board and let's discuss.